All right, so greetings, and let's look at statistics in R programming. Um, if you are seeing my YouTube for the first time, uh, I have a class that is ongoing, and there are some people that I take them through. And so you are welcome to the class if you want to join from here. Um, what is it? We're going through a lot of things, or we have gone through a lot of things, stuff, and then we are at this particular point, statistics in R. So let me share my screen quickly, and then I don't intend to make this presentation a long one. I think as I choose this one, yeah, I'm much more comfortable with that outlay. Yeah, so this is just RStudio. If you are not familiar, this is RStudio, and I have my sliding windows up and down here. This is actually where much of data analysis is being done. So if you're not conversant with RStudio, and for that matter, you can check on my YouTube channel. I have series of videos on basics of R and then stuff. So today we want to look at statistics in R. Now, when we are looking at statistics, we are actually talking about most of the averages that we use in calculating or in getting our average values, and then we are able to make any informed decision. And so I want to base my analysis on this. I have already built some data sets. I taught a lesson on how to be able to get your data into R environment. You can actually do that by going online. And then when you go online, you want a data set which is seated online somewhere, then you want to get it into R. It's actually that easy. It's very easy to be able to do that. And so because of that, I've already imported the data set, and then it is here. But if I don't want to waste your time on this, this is where I actually done the teaching. I'm now coming to record a video. So I'm leaving this particular line out. So I'm just going to go up a little bit. And then this is where we are. I have this particular, I taught this particular lesson as to how to be able to import data into R. And so we have imported the data. We created the data using our Excel sheet, which is here. And so I just, what is the way, you can actually come here, save it in a CSV file format. And then when you go to your RStudio, there are several ways of importing it. You can check the video as to how to import data into R. I have a video on that. So when you come, we imported the data, and then we decided to bind it. There were 3 different data sets. We decided to bind it. And then we bind the data set using this particular command, which is called, we use rbind. It's a function. So this was one of the data sets. This was the second one, and this is the third one. So we bind it row bind. So it means we put one under and put the other one under, and then it became one data set. So we pack that data set into this, and that's what I'm going to work with. So now, if I come and I want to apply this particular data set, I just need this variable here, which is seated. So I came down here, and then all I did was to make sure that I attached the data set. So let me remove this particular line here. I decided to attach the data set, which is called student student population under KNUST, which is here. So when you do this, if you run this function called attached, what you are doing is that you want to separate all the, for instance, it is here. We have student P underscore KNUST. So if you put a $sign to it, you are going to see these are the column names. So it starts from column A all the way to I. And so what you normally can do is you come and use attach function here, and the attach function will allow you to detach all the columns to now stand alone. So if I come here and I just write A, because I have run this particular function called attach, then the attach is going to mask some objects out, so it's all right. Now, if I come, I can print only the column A, and that will, so these are the figures in column A. Now let's apply our statistics on any of them. So I will now be picking some of the columns one after the other. If you want, you can also create your own columns. or you can create your own vectors and apply the statistics on it. The first statistic we want to apply is mean, the mean. And then the mean has a syntax in R programming. If I want to say the mean, you want to remove some externalities, the first part of the values and then the other part of the values, then in that order. So NA dot this means if your data set has some kind of NAs, you need out. So what we are saying is that I have a vector called, I am taking this data from the KNUST student population, what is it, data set I just showed you momentarily. So if I want to find the mean of all those in column A, maybe column A could represent their age, their scores, or whatsoever. All I need to do is to simply come and say the mean. I have my mean here. Then I just put the A inside. Remember, we've already created the A, and so that's the mean over there. But not all the time you do it this way. Perhaps, let me print the mean, what is the vector A again, and you look at something. These are the values. There may be instances you just want to print the mean, but you don't want to include maybe some part of the data. That is, if the first part or the last part, you use the function called trim. Trim, you can't trim anything in the middle, you trim the ends. So I will come here and I will say, let's say I want the mean of A, and so I'm just going to type A. But in this case, I want to add trim. So if I put trim, I can come and say 0.3. So what I'm simply saying is, oh, why am I think, so I can come and put here. Okay, so I think I should press on there. In fact, because I'm doing tutorial, anytime you see this kind of your cursor turn into underscore, go to your keyboard, you see something called insert key. Come and touch on that. You should change it back to a vertical line. That's what I've just done. So my trimming is going to be equal to 0. Why? 0. I think. Yeah, okay, that part was blocked. 0.3. And so what I'm simply saying here is that I want to calculate the mean of the vector A, but I want to remove 30% of the first part of the data, and then 30% of the last part of the data, and then the rest I'll calculate the mean. And so this is what I've done. In any case, what I've done is, it means that I have taken this part of the data out. So I have trimmed the first part, the 3 out here, and I also came and took this particular 3 out, and that's what I've done there. Now, the next thing, there are also instances that the data set could have NAs. NAs means not available. For instance, if you've gone out to pick your data and then you come back, maybe you've gone out to pick up the data and it is just one vector of people response to something. There are some people that may not even answer you. And so what is those particular category, what do you say? You say not available. That is, if you are booked for them to answer the questionnaire and then you come and they are not there, you don't write 0 there. 0 is a number. So you put the NA. And that's what we are saying. So when you have your data that has NAs not available in them, you have to make sure that you are able to take care of that one. And so when you are calculating the mean, like let's say I have the mean, let me pick another variable there, and that could be E. For instance, if I print E, you will see that E is here. So let me introduce NAs into E, and then you look at how it's going to work. So that's E, and then I'm going to introduce NAs into E. Already, the data doesn't have NAs in it, so I'm going to introduce it. So if I say E, or I can just put something like this. So if I say 1 here, it means I am printing the first value of E. So it will print 38 for me. So I have printed 38. When you use this function, the square bracket is called index function in R. So in the index function allows you to be able to look for the position of that particular data variable. So all the data you have here, 45, 18, whatsoever, they are occupying positions. So the first one is position 1. So if I put the index function and I put 1 there, I'm saying print the first value, and that's what I'm saying. So here, if I should put 5 there, it will print the 5th value for me. So you see that my 5th value is 1, 2, 3, 4, 5, which is 45. And that's why it printed 45 here. That's how it is. So if I want to print, let's say, the values in series, I can just say 5 is to, let's say, to 10. So I want to print all those values that occupy the 5th position to the 10th position. That's going to give me my value, and that is there. Now, if I want, so in that case, let's assume that I wanted to introduce NAs in 3 different positions. Let's say I want to, or let's say I wanted to introduce NA at position 4, and then 11, and then let's say 15. So I will have to have the vector there, come and use the index function. But because I am printing values which are not in sequence, I have to use a vector sign. So I'll put C there, and then come and do like this. And then I'll say that position 4, position 11, and then position 15. If I do like this, is if I print it like this, you notice that those values are 35, 45, and then 31. Now, let's assume that those positions, I want to replace them with NAs. So I simply come here and do this, and then I'll just write the NA. So now, if I do like that, this NA is going to occupy position 4, 11, and 15. And so now, if I print E out, if I come here and then I print E out, you will notice that E will now have the NA at those positions. See NA here. You can see another NA there. You can see another NA here. So now, if I am going to calculate the mean of E, I will not be able to calculate it because there are some points that were not available. That's the point I'm trying to. So I say mean. I just come here and I put E. Now E has NA, so it will return NA. So you notice that it will say the average cannot be found. So in that case, what do? You simply come down and say mean. You have your mean of E, and then perhaps you go ahead and then say that NA dot, NA dot remove. So this particular function is going to come, and then you say true. You are saying that the function should remove all data points which are NAs, which are not available, and then the rest, put all of them together and calculate your mean. And when I do that and run it, so now it will come and calculate my mean. Has decided to calculate my mean for me. The first one, the mean was 34.1. So you have certain positions here, and then of what E or any of the variables. But in that case, I already know that E has NAs. And sometimes, before I even say this, let me say this. You have to check to know whether the data has NAs or not. So you simply write the function is NA there, and then what are you finding? You are asking a question. Is there NA in E? Are there some vacant places in E? It will return a boolean. So wherever you find true, it means NA is there. You can see true is here. You can see another true is also here. And this is how we are able to find out. So once you know that there are NAs inside E, then you have to now come and then calculate it and make sure that you take care of the NAs. But in this case, you want to take care of the NAs and you still want to calculate it without adding some kind of values. Okay. So what are you going to do? You are going to find the mean. I'm going to say the mean like this. If I go inside, I want the mean of A, and then I am simply saying that I want to exclude some parts of the data. Okay, I want to exclude some part of the data. The data in total, there are 81 data points. So let's say I want to calculate exclude the last part of the data, and then so I will simply say NA dot remove, which is equal to true, and then my next point is that I want to exclude some part of the data. Which part is that? Let's say if I want to exclude that part of the data and then it is in series, what I'll simply say is Okay, from 60 above, I don't want those ones to be passed. So I'll just say 60 or 60 to 81. If I say 60 to 81, it means that, and then without anything, because I don't want 60 to 81 to be there, I'll add negative to them to 81 like this. So they will not be. So it means we are calculating our mean with this particular vector called E that contains 1 to 81. But we are excluding all the data points from 60 to 81. And the rest too, we are also removing all the NAs. And whatever is left, we calculate our mean from there. And that's what we have just written. So I think there is error in mean.default E. Trim must be numeric. Oh, where did I put trim? I can't see where I put trim. Okay, so let me quickly correct this. Then I remove this. Then come here and say trim the last part. So the last part, I'm going to say trim is equal to 0.8 and then comma, and n is removed. Yeah, so that calculates it. And then I have 38. So these are the various ways through which you can calculate your mean. You could have also gone ahead to calculate the mean by not using attach, but you could just come and say the mean, and then when you come here, you know the data set already. It is students P, student P, and then you select the column. So in this case, let's say I want to select column F like this. I can just find out the mean. It will go ahead and calculate the mean for me. This is how we are able to do mean. If you understand mean, median is practically the same. The only thing, the difference is that we don't, if your data are integers or they are count data, like you count the number of students in a class, count data, you don't actually apply mean on count data. You apply median. Mean is mostly used in metric data. Metric means a data point that has been measured, like height, weight, oxygen concentration and all those things. They are measured. So we use mean. But if they are count, like you count the number of chairs, you don't use mean, because you cannot have half chair. And when you calculate mean, you could get like 2.3, this and this. And so those ones, that's why we don't apply mean there. So if I come here, I could also look at median, and median is practically the same. Let's say if I come and I say I want the median of, I just put the function median, and then I can say the median of A. Then it will return the median value. So you can see that it is A. If you also know that, which one has the, like E, the median of E. So if I say I want the median of E, put like this, I have to say that NA dot remove should be there, and I'll have to say true. If not, because it contains NA, it will be able to return the median for you, and now the median just returned properly. So that's how we are able to do that. There are other statistics like SD, which stands for standard deviation, or sometimes like variance. I could come here and then the variance of A. Let me try. So the variance of A is actually 142.3. That's the variance. You could also try standard deviation. I think standard deviation is something like this. Yeah, standard deviation, and then standard deviation error. What is it? And then you just put the value inside, and then it will calculate your standard deviation for you. But if you know your variance, it's very easy to calculate your standard deviation. You see, the square root of your variance gives you the standard deviation. So all I need to do is to just find the square root of this. And then, so I would have packed this particular value. I would have created a variable and then put the, so I'll just say SD, and then like this. And then if I write it, the value will go into that. And then when I come, I will say that my standard deviation we just will now be equal to the square root of the SD that I've already calculated. And then that should be able to give me my standard deviation. When you print that, your standard deviation is actually 11.92. So is that very simple? That's for standard deviation. Now you can calculate your variance, your standard deviation, your standard error. So the standard error, for instance, if I come here and I say STG, you can see your standard error which is out there, and then you can also calculate your your dispersion, and then all those places. You can check that in my extended video tomorrow. Now, these are the very basic. In R, we don't use ordinary mode to be able to calculate mode. We use a function to be able to calculate mode. And I'll be teaching functions anytime soon. But when you check on my YouTube videos, you have a lot of videos on functions, R functions, and then stuff. They're all there. Now, the next thing we want to look at in terms of statistics in R is something we call linear regression. Linear regression. So we have something like this is what I'm trying to linear regression. So here we are looking at two important things. You have one data set, you have another one. One is a response variable to the other. So two variables. For instance, you want to check whether the scores a child obtained in class, does it have any relationship with the number of times he attends class or his attendance? So you have one part of the data being attendance, another part being the score. So the score is a dependent variable, then the attendance is independent. So the score is actually the response variable, the independent is the predictor. So sometimes we use these words interchangeably, just get them straight away. So to be able to do that, let's say I am using my same vectors, which is A is here. Now come and look at who is here. Let's them down. So I am going to it will make sense for us. So I'm going to call that score. I just assign A to it. But in that case, I think I should break them into a much more reasonable. So if A are the scores, I'll leave that one, and this B are the attendance. I will divide that one by 4 to make sure that I have a very small number of attendance. In any case, it doesn't really matter. This is so attendance, and then our attendance is equal to B. So I'm just going to run the two of them like this, and then I have them run. So the next thing is to find out score the attendance. I mean, how does the attendance influence the person's score? I won't be able to make any sense from that. So the best way is to actually try and plot a linear regression. And the regression model will let you see if there is some kind of relationship between them. If there's no relationship, then we go ahead. Now, let me go ahead and then do this. To be able to do that, you build your relationship. So we have something here. I'm going to shorten it as function, and then this function called LM model. So yeah, about regression. So the linear model I have here, you always have the first so I'll come here and say the score. Why it come? So I'll come there and then write programming means explain. So this one is explained by the attendance, attend, which is here, and then that is all. I'm not going to do anything else. I just run that. And so when you come here, you can see we have packed the results into this called relation. I have my relation, it is here. So now when I print it out, you can look at the your resource here. The resource is saying the coefficient is 41, and then you have a negative 0.167. And try and extend. Don't want the video to be extremely too long. So here, the intercept is actually 41. The intercept is this, saying that even if the child did not attend even class for one day, zero attendance, his score would have been 41%. And that's what intercept means. Intercept means that the response variable, the intercept is the response, is the value of the response variable if the independent variable or the predictor is 0. Understand this, and then you are good to go. As long as there is an intercept, the intercept always mark the response value. It's always the response value if the predictor is 0, or it is the value that the independent acquire. The dependent acquire if the independent was 0. It means if there was no influence at all. For instance, if you were dealing with agricultural input, and then like factors of production, and then how to be able to see the influence on output yield, then you realize that when you plot it, your yield against your fertilizer is your independent variable, your yield is dependent. And then you realize that intercept is, let's say, 2 bags. So it means that if you didn't apply even 1 kilo of fertilizer, the harvest would have been 2 bags. And that's what it means. Okay. And so this is how we are able to do it. If you want more information about this, you always come and then you have summary of the model. So I have to have a summary. I just put this there, the relation there, and then that gives you a much more clearer information. Let me pull this up. So you see, you want to have your model, which is here. You have your residuals, you have your mean, your median, your quartile, your maximum. Your coefficients are here, estimates are here. Look at your p-value, which is also there. Come and look at degree of freedom. If you want to understand all these things that I just printed, watch out for the next video tomorrow, and then I'll be doing another thing that will be basically on regression, and then that is it. So this is the video of today, a little introduction to statistics. We'll do a whole lot of things about this: normal distribution, Poisson distribution. We'll go to hypothesis testing and all that you can think about in statistics, standard deviations and what they mean, skewness. We'll do all that here. So watch out for my next video, and I'll be explaining much more details on how to interpret see. But this particular value is significant. It's at p-value of 1.14 times 10 raised to the power minus 11, which means 0.0000000. So the actual p-value is here, which is 0.1. It's not, and then we can see our F statistic just has 0.00. This, so it's actually 0.9%. That's a bit bad. So when you plot something like that, it means the model cannot give you accurate prediction, and this is just a simulated data. So what do you expect? Thank you, and then I'll see you tomorrow in another video. Bye bye. All right, so that has been your video of today. Please, if you enjoy what I do, why don't you give me a thumbs up, share the video, invite other people, subscribe to it, and then you support the channel, and then let's grow together. What I do here, basically education, capacity building, just to make sure that, we are all a part, and that's all I do here. I don't have subscribers, just 172 subscribers, and this is woefully inadequate. And I put in a lot of resources to be able to put some of these videos together, and it's not easy. The data alone, whatsoever that you are seeing here, make clear, there are lightning and other things from back, and also from my own resources. I don't have anybody who is assisting me to be able to do all these things. So the least you can do is to subscribe and also share, and then allow other people to also subscribe, and that is the only way that it can help me. Thank you.